the last language in this marathon before we take a break is the C++ language. So the code generator goes from STG in one step to C++. And I don't have a great deal. I don't think I sort of was running out of steam by the time I was writing this little bit. So I've just satisfied myself with just to give you a quick picture of the directory. So there's a C++ directory, CNN. And the main data type is in cnn.hs, and it's a supporting file for machine operations. So this is like which are the single instruction machine operations that are available. But CNN is the main file. It's not a terribly big data type. And it's a Haskell data type that pretty much faithfully describes the CNN data type of the C++ language that Norman and I have worked on for some time. And so it turns out to be a very nice intermediate step between this rather functional stuff. C++ is very imperative. And this is just exactly the purpose that C++ was meant for. And even though we may or may not go through a C++ compiler, in effect, GHC is a C++ compiler now, because it can take the C++ stuff and generate C or machine code. But it doesn't attempt to tackle all of C++, just the bits that we needed. So it comes with two pretty printers, in fact. PPR CNN is a pretty printer that pretty prints C++ using C++ as syntax, and PPRC is a pretty printer that pretty prints C++ in HC syntax, ready to go to GCC. Right. So that's why there are two pretty printers here. There is some kind of consistency check. Thanks, I did what it does.
Checks types.
There it is. It does some kind of type check. Very good. So simple type check of C++. And I think there's quite a lot of scope for a C++ to C++ optimizer. And this is the one that's here at the moment is pretty simple-minded. One thing that was missing from the glorious picture is that when there are some modules in the runtime system, which you're about to hear about, which link very intimately to code generated by compiling Haskell. So in effect, it's kind of like handwritten C++ code that you couldn't actually write in Haskell, but which has all the same entry conventions. It is as if it was a Haskell function. You're writing a function in C++ you couldn't write in Haskell because it uses some, meddling with the operating system. But its interface, its external interface, all its calling conventions are exactly like Haskell functions. So, how are you to write that? Well, we want to write it in C++, so we want to, and then we want to turn it into runnable code. So to turn it into runnable code, we really have to generate an HC file or assembly file. So to turn these handwritten bits of C++ into runnable code, the obvious thing to do is to read it into GHC and use GHC's backend to turn it into runnable code. We used to write these in HC only. We used to handwrite them in HC, so we used to handwrite them in this form. But that meant that you could only turn, it would mean that to compile a runtime system, you had to have the magic GCC route available. Whereas now these special handwritten bits of runtime system code are written in C++, we can parse that C++, feed it in here in the compiler, and generate machine code with the native code generated route, and you don't need this magic HC registerized with one evil mangler stuff at all. That's good. That's a step forward in the last little while. It's driven by this C++ thing. So you'll see in the runtime system some files that go foo.cnn, and those are the ones that are read in here and go down this route. Yes?
Are there any deviations in the C++ from the definition that we should know about?
Are there any deviations from C++? Do you know, I don't. I think it's more specialization. So C++ allows you to have registered directives to say, put a register that I'm going to call HP in EBX. Right, so, but C++ doesn't know about HP being special, so a C++ compiler needs to allow you to declare arbitrary register directives. In this C++, there's a particular pre-baked set of register directives. You can't write register directives in your C++ file and have them. They're just baked in, even baked into the data type. So it's more like a slightly specialized version. Yes. So you couldn't really use this as a general purpose C++ compiler. It's more like a rather specialized C++ compiler.
And the C++ concrete syntax has a bunch of macro-like things that get expanded by the code generator as well. So conventions that GHC's code generator knows about, the layout of info tables, closures and so on. You can express using macros in the CNN concrete syntax.
Yes, the exact layout of a heap object, the knowledge of where that is something you have to be rather careful about to make sure everyone agrees. And so the place that knows about it is actually a bunch of procedures that generate C++. Say, there's a procedure that generates the C++ for allocating a heap object with this kind of payload, and that's used both by the code generator and by these runtime systems C++.